Hello everyone. Our experiment today is the boost. Last time we took the buck chopper and today we will demonstrate the boost. It's almost the same experiment, but you need to do some changes. First of the things that you need to add or that you need to use, two resistive boxes. Why? If you look here at the rated value for each resistor box, it says 120 volt. Okay. And this one here is 120 volt. In this experiment, the output will be huge. The output will be high. The output will be up to 240, 250, almost 300 volt. So if we just use one box, it cannot handle. The heat will increase and it can burn. So that's why we use two resistive boxes in series, where each box is only 400. So we can use one box, 400 from here, from this column, and 400 from this column. But no, we're going to use 400 from this module in series with 400 from this module. So that's why we're going to have two resistive boxes in series. That's one of the things that you need to pay attention to this experiment, and this is the first time you've seen this. Another thing is the smoothing inductor. Last time we used both, now we're going to use one, but look at the connection right here, because last time in chopper, the buck chopper, the value what needed was 0.8, so we connect 0.4 in series with 0.4, so we get 0.8. But here, the value needed is 0.2, so we will connect this coil with this coil in series. I mean in parallel, so it will give us 0.2. Okay, so this is the only thing that we will connect. Here, last time we ground the Q4. We ground the Q4 in the buck experiment. Okay, which is okay. We ground last time. Sorry, we ground the Q1. We ground the transistor 1. Okay. Sorry. In buck experiment, we ground the Q4 because we only need the diode from Q4, which is in the previous experiment. You can go back and look at it. Today, in this experiment, in the boost, we will ground MOSFET 1 or transistor 1 or Q1 because we need the diode 1. So we're going to use the diode 1, but we will ground the Q, which is connected parallel to it, because we are using this time Q4. Okay, so that's why we ground Q1 today. Here you can see that. I'm gonna bring the camera later and show you. And in the buck experiment, we grounded the Q4. So the ground was Q4 because we used Q4. We used diode 4 in the buck experiment. But today we're going to use the diode number 1 because we are using the Q number 4. And we explained last time why we use a diode to release. We don't want to have, we want to protect the MOSFET, because if we have no path to release the current, we will have a huge volt and it will be damaged. The rest here will be the same. And I want you guys to, before you watch this demonstration, I want you to watch the lecture, please, for the boost. And they will be posted at the same time, the boost lecture and the lab. But I want you to watch the theory before you watch the demonstration for the lab. And I want you to put in mind the equation for the V out, which is V out for the boost. Last time, the equation for the buck was V out equals V source times duty cycle. The equation for the boost is V out equals V source divided by 1 minus duty cycle. So when we increase the duty cycle, imagine if the duty cycle is 0.5 So if the V source is 100 divided by 1 minus 0.5 is 0.5, so 200. So it will increase. But if I increase the duty cycle and make it 0.75, so now it will be 100 divided by 0.25, so it will be 400. So the V out will be 400. So when we increase the duty cycle, the V out will increase. And that's what we will see right here. Another thing is the capacitor. The capacitor is already, you don't see no capacitor right here because it's already built in the MOSFET chopper. And you can see it right here, it's already built in. It's the capacitor right here, okay? That's the capacitor right here. It's already built in. And the capacitor, as we explained today in theory, which you need to refer back to it, it will help. It depends on the size of the capacitor, but the bigger the capacitor will make the capacitor almost straight. Will make the capacitor almost straight. And you guys took this experiment in electronics before this course. Let's see now. I'm going to bring the camera and show you. Okay, let's see here. As I told you, this is the load right here, and everything is down except those two, which equals 400. And in series with this, okay? The experiment is almost the same as last time. But now we come to the smoothing inductor right here, and then we go to the isolator, current isolator, and then from the current isolator, you see here, we are targeting Q4 now. We are using Q4, so we come to the Q4 here. Here, that's Q4. Okay. And then out from the Q4 back to the neutral. And then we use this diode right here. This diode one. Okay, so we go to from diode 1, output from diode 1 to the DC current, and from the DC current to the load here. Okay, so that's the circuit. And here we grounded Q1. That's the ground. Last time we ground Q4 because we use, last time in buck chopper we use Q1, transistor 1. But now we are using transistor 4. So that's what you need to pay attention, because the location is different. Before in chopper, the location was right here. The location was, you see that, as I told you, counterclockwise. It was, so in, this is a boost. Okay, if you counterclockwise right here, okay, this will be here, and this will be here, and this, and that will be here. Anyway, let's see here. We are supplying, we don't want to supply a huge amount of voltage, only like a 20% here, because now this is the boost, we're gonna have a huge voltage. This is a 20%. And let's see here, okay. This is the frequency minimum. It's pulse width modulation. I need to put it in pulse width modulation. Number 2 now, okay. And see here. Now I am supplying 20% volt. And here, when I increase the duty cycle, see what will happen, guys. I will increase the duty cycle, and look here what will happen when I increase the duty cycle. See here the voltage, okay? I'm increasing like 50%. The duty cycle is 50% right here. See how much I have. The source is only like 25%, 25 volt. That's the source. But look how much I have in the output. I have like 80 approximately, 80 volt. Okay. And that's here, that's the voltage and current. Okay, let me stop. Okay, look here. That's the voltage. It's almost straight. There's a small ripple right here that you can see, but it will be like this. It will be straight because we have a capacitor inside built in, and it's used now. we have the capacitor. That's why it's straight, almost straight DC. And that's the current. Charging, discharging, charging, discharging. Okay. I will leave it running. See here, I will increase. I will increase more, 75%. That's 75%. So still the same, the source, 25 volt. Look at how much I have in the V out. Okay, I have almost 130 volt. Okay, and that's increased. See how the capacity, how it's changed. It's increased, and this is also changes. Okay, I will let it go. I will increase more, guys. I cannot make it 100%. The maximum that I can have is close to 95, 96. You see the noise? See how much here? That's, it cannot. Actually, the maximum you will get with this is like 250. So the maximum point is 250. That's the maximum. You see here? Okay. I cannot leave it like this. I'm gonna leave it half, 50%. That's 50%. And that's 50% right here. Okay. That's why we use two resistive boxes, because the voltage will be huge. See here, that's the output voltage. It will be like around 250 to 300. Okay. Look here, that's 50%. Let me see here. If I play with the frequency now, this is the frequency. It's minimum. If I increase this is the frequency here. If I play with the frequency and increase, look what will happen there. That's the frequency here. That's the maximum frequency. What happened, guys? Can you tell me what happened in for the current? The current becomes straight, no ripples. So we get rid of the ripples. We make it smooth. Okay, see here, I will decrease the frequency, That's I decrease the frequency. You see the ripple now? Big ripple. So increasing the frequency is making the current smooth. Okay? Smoother. Okay? That's the whole thing, guys. And nothing is new. And that's the experiment right here. Okay. So here, that's the 20% that we put it right there. And that's they ask you here to put the control unit DC source 1 for 90%. Okay. Actually, we are going the opposite here. Okay. That's 90%. That's 90%. And they're asking you how much is the volt. Okay. The voltage is like, as I told you, 200 to 150. Okay. Describe how the DC voltage MOSFET boost chopper. Okay, it's okay. Here you can look at this answer, no problem. I know that you're doing this all the time. And here you can draw here for 50%. This one here, that's 50%. Okay, that's the 50% here. And I think you're gonna see it also in the theory class. See, that's the blue is the V out and the yellow is the I out. Okay, here you can look at this. This is still the same, no change. Okay, and then they want you to see the V source how much and apply. They want you to, this is the V source 25. That's what we have, and they want you to apply the equation, which is V source divided by 1 minus duty cycle. It's not 125, it's 250, because the duty cycle is 0.5. So the V source, no, here is like, okay, it's 0.25. Let me read how much they're talking about. Okay, they want DC source 1 to be 90%. DC source 1 to be 90%. So that's 90% here. That's 90%. Okay. And they said, how much is this? So you need to do the math. You need to do the math. So 90% means it will be 25 divided by 1 minus 0.9. So 25 divided by 0.1 is 250. 250, okay? That's 250. Okay, that's what you need. Okay, you can calculate this, and also you can look at this. You need to know how to find this, guys. That's the experiment, guys. Okay, that's the boost experiment, and I think we're done with all the experiments for power electronics and also for the theory. And I wish you a good luck, guys.